Dear students, welcome to our science episodes. Today we are going to discuss atomic structure of matter. Atomic structure of matter. These are symbols for some elements: sodium, calcium, iron, oxygen, helium. Why do chemists use symbols for elements, or why do scientists use symbols for elements? To express and study them easily. And what do you notice from these pictures? Yes, they are colorful, of course, but what do you notice from these pictures? The symbols represent one single atom. So if I'm talking about this, so this is an atom of a sodium element. If I'm talking about this, so this is an oxygen atom of the element oxygen. The symbol is one letter written in capital format. So if it is one letter, it's written in capital. If it is two letters, if they are written using two letter symbols, so the first one will be capital and the other one will be small. Some elements are written using two letters instead of one letter because they share the first letter with other elements. Like, for example, the calcium and carbon. We cannot put both of them C. We cannot write both of them C. So we write calcium Ca and carbon C. When the symbol is written using two letters, the first is capital and the second is small, as I said before. Some symbols are written using the Latin name of the element, not the English one. So, for example, how come it's sodium and written Na? Because it's written after its Latin name, not its English name. Its Latin name is natrium. So that's why it's written Na. Potassium, for example, it starts with P, but its symbol is K, after its Latin name, kalium. What do you know about atoms? Atoms are the smallest units of matter. Are they smaller than molecules or larger than molecules? Of course, they are smaller than the molecule. They are the smallest basic units of matter. They are even smaller than molecules. They form a chemical element that can participate in chemical reactions. The atomic structure, it's in front of you. Look at this picture. We have a nucleus at the center. This is the nucleus. The nucleus of the atom, it's the core or the central core of the atom, and it contains positively charged particles called protons and neutral particles called neutrons. So the protons are carrying positive charge. They are positively charged. And the neutron, they are neutral. They do not carry either positive or negative. They are neutral. So we write it as plus and minus together. It means that they are neutral, neither positive nor negative. Protons and neutrons are found in the center or in the nucleus of the atom. And we have electrons, or here we have electrons, the green electrons. They are negatively charged. They carry negative charge. And they revolve around the nucleus in orbits. These orbits are called energy levels. They move at a very high speed. The number of electrons is equal to the number of protons inside the nucleus. So, if we have 1, 2, 3, 4, 5, 6 electrons around the nucleus, so definitely we have 6 protons inside the nucleus. The protons are always equal to the number of electrons. And electrons have negligible mass. Give reason for. The nucleus of the atom is positively charged. Why? Can you think about it? Because the nucleus contains neutrons and protons. Neutrons are neutral. What about the protons? They carry positive charge. So this makes the nucleus positively charged. the mass of the atom is concentrated in the nucleus. Do you remember when I said that electrons have negligible mass? That's why the mass of the protons and the neutrons inside the nucleus, they make the majority of the mass of the atom. That's why we say that the mass of the atom is concentrated in its nucleus. The atom is electrically neutral. This is because the number of the positive protons inside the nucleus is equal to the number of the negative electrons in the outer energy levels. So we have electrical balance between the nucleus and the outer orbits. To express any atom of any element, we use two terms: the atomic number and the mass number. The mass number is the sum of protons and neutrons in the nucleus, and we write it upper left. The atomic number is the number of positive charged protons, and we write it on the lower left. So this is protons plus neutrons, we call it mass number, upper left. This is protons or electrons, it's called atomic number, and it's placed lower left. What is meant by atomic number of chlorine is 17. Look to this. This is chlorine. Atomic number is 17, lower left. This means that it has 17 protons in the nucleus and 17 electrons in the outer orbits. What is meant by mass number of chlorine is 35. Here, the mass number. This means that the sum of protons and neutrons inside the nucleus is equal to 35. Therefore, we can conclude the following. Atomic number equal number of protons, which is equal to the number of electrons. Mass number equal number of protons plus number of neutrons. And number of neutrons could be calculated by subtracting the number of protons from the mass number. Time for questions. Can you calculate the number of neutrons in a sodium atom if its mass number is 23 and atomic number is 11? The atomic number, which is 11, is equal to the number of protons. And we know that we can get the number of neutrons by subtracting the number of protons from the mass number. So 23 minus 11 equal 12 neutrons. Now, suppose this is the nucleus of a fluorine atom with 9 protons and 10 neutrons. Can you calculate the number of electrons, atomic number, and mass number and write down the symbol of the element? By the way, it's very easy. The atomic number equal the number of protons, which is 9, and the number of electrons equal the number of protons, which is 9. The fluorine mass number is the sum of the protons and the neutrons. So 9 plus 10 equal 19. And fluorine symbol is F capital. 19 is the mass number, upper left, and 9 is the atomic number, lower left. Now, write the scientific term. The smallest basic units of matter that form a chemical element and participate in chemical reactions. Atoms. The number of positively charged protons inside the nucleus of an atom. Atomic number. The sum of protons and neutrons inside the nucleus of an atom. Mass number. Write the chemical symbol. Sodium, Na. Hydrogen, H. Chlorine, Cl. Aluminum, Al. Calcium, Ca. What is written below left? Yes, this is the atomic number. Dear students, thank you for watching. See you later in other science episodes.